students tend to make less mistakes. Well, all people. So this theorem, this factor theorem states if the binomial x minus r, meaning r could be anything, is a factor of p of x, p is just the name of a function here. So if a binomial is a factor of a function, the remainder will be 0. So the remainder of 0 means that divisor is a factor. So you're going to search. You're going to do different numbers with synthetic division searching for factors. And that is how we factor these really long problems. We do synthetic division and try to find the remainder of 0. For this one, we're going to put -2, right? So for number 2, what we're going to do is synthetic division. It's actually 3 problems. We're going to do synthetic division with this divisor, with this divisor, and with that divisor. So the same problem, this dividend, with 3 different binomials. We're hoping to find one that has a remainder of 0.
No. I think it's C.
Just guessing?
Right.
Why'd you guess C?
I got it right.
Okay, so if I want to do my synthetic division, who can tell me what my numbers are going to be inside the box? This top row, Gabby? 1, -3, 2, 4, and 4. Okay. What number is going to go outside the box? Joanna? It's for A, right? Yeah. -2 is outside. Right, because we take this little guy, we set it equal to 0, and we solve it. So we got a -2 right here. So one of the, points in the synthetic division yesterday, the definition was that you just use the coefficients. You have a problem here, we don't have to deal with the x's and the exponents. We just have coefficients. So we're going to bring down the 1. Let me do this like I've never done before. Multiply by -2. And then add. Multiply by -2. -5 times -2 is 10. And then add. Multiply by -2. -24. And then add. Multiply by -2. Am I good? Everybody matching up my numbers over there? Positive 56. And 60 is our remainder. Go ahead and write the quotient itself. The result would be x to the third minus 5x squared plus 12x minus 28 plus 60 all 60 all over x plus 2. Okay? Who's got a question? letter B. I'm going to put a positive 3 on the outside, the same top row. Yeah, we're doing the same thing 3 times with different numbers on the outside. No, I don't do that. I just get them and then I whatever. Okay. Everybody check letter B. Did you have your remainder 10? Letter C, which rumor has it is the answer. Remainder 0 answer. I'll put a 1 on the outside. Sorry, you need to do something like that. 1. You can, but no, I guess you wouldn't. I wouldn't take off. I wouldn't take off. No, it's not like not simplifying a fraction like that. It's just it's fine. Lord, that is so much quicker than long division. Well, this would be the third. This one would be squared. So this is x to the first. No, this would be x to the third. This one is x squared. That'll be x to the first. So for that reason, if you want to put the 0x squared in so you don't make that mistake, then I encourage you to put the 0 in. So it's x to the third minus 2x squared minus 4. I guess. I'm going to write something here. I'm going to give you a preview. So in letter A, the result was 60. So I would say, if this was a function, I would say f of -2 equals 60. Letter B, I plugged a 3 in. I would say f of 3 equals 10. In letter C, f of 1 equals 0. Yes, so it's x minus 1 that is the factor. I put a positive 3 here. What's that? I put a negative 3 here. And then when I added on, I got negative 2. Oh. Talking about this box, right?
Oh, yeah, probably.
Okay. I could have written it like this. X to the third minus 2x squared plus 0x minus 4. This is the answer down here, not anything to do with that negative 3. I gotta look at Desmos for a second. So this is x to the fourth minus 3x to the third plus 2x squared minus 4x plus 4. I'm gonna put this in Desmos, try to make a connection for you about graph. I haven't tested it yet. X to the fourth. Minus 3x to the third plus 2x squared. You guys see how all of these terms are changing this graph here? Minus 4x plus 4. Okay.
Why is it so different on both sides?
So this is the graph of this polynomial function. It's not symmetrical. These functions that have all of these sign changes, they are not symmetrical. When we graph, there won't be any line of symmetry on the majority of them. Some of them are. So we found remainder 0 for 1, and that shows up in this graph. Can anybody see where 1 remainder 0 shows up in the graph? Jackson, it's not on your phone. It's up here. All right, 2 people see it. Anybody else see where 1, 0 is? 3 people see it. 4. Okay. All right, Paige, go ahead.
It's at the coordinate 1, 0.
Here's 1, 0. So when you find remainder 0, you found an x-intercept. So we're going to work towards making these really complicated graphs. And the way you do it is just doing this over and over again until you get remainder zeros out. Other remainders are beneficial too. Can anybody find 310? 310 on here?
Yes.
That's an ordered pair.
There's
Negative
1, 5.
260. Do you guys think negative 260 is on here?
It definitely
Definitely
is.
is. Right there. There. See, so anyway. Synthetic division is used to find points to make graphs. And remainders of zeros are x-intercepts, which are solutions. And other remainders are really helpful too because they're just other y values. So as we move towards making these really unique graphs, we'll rely pretty heavily on synthetic division to get us there. Where's the graph? Yeah. All right. Get out your homework. I'm going to put the answers up, and at the same time, I want you guys logging into a Chromebook. No, it's a different thing I've never done before. I'm trying it out with you guys. I wanted to make sure that you practice synthetic division in a meaningful way, so I'm hoping this activity will make it memorable. Because it's easy to see through it and then never remember it again for the rest of your lives. Please feel free to take a minute and check your remainders on these answers here.
How does she read homework?
I'm walking around right now. Keep your workbooks up. I put up the answers so you know if you got your remainders right. Oh, yes. You're up, right? Hey, Denise, how are you? What? what I'm
Did I
doing.
do my left?
I don't know what it is though. I can't tell.
No, it's at 100 over. What'd you get?
34 over.
3, 7, plus 3, 7. Well, in this one you should.
Oh, that's
Wow, you just wrote this problem.
You get 100, Des?
I did.
No.
Can you go for 16? This one needs
I got
0.
96.
Oh. You want me to 16? Yeah, because that ain't right.
Wait,
Alright, the activities and
can you tell me how many I haven't done this quarter? Is it 1?
Okay, wait, so what's 13?
Alright. How much time do I have? Every single day.
Oh,
Hang on. It's got beautiful. Beautiful. You're beautiful. I want to start lemon bread.
yeah, and then 17.
You got purple?
It's on Schoology. The activities in Schoology.
Oh, that's like, that's not me. That's just not, I'm not a type of dude. No. Shirley, what? I don't have school days. What color is it based on?
Green. Here's your numbers for 16. You got a -5 out.
So weird. I'm not that color, dude.
Okay. In 17 is 0. So your top row, so you can put a 0 in. Who said 17? You did?
No, it's definitely.
There's 17. You said 14, Savannah? Yeah. What? Yeah, go to Schoology. It should
won't let me
say.
do it. It says I need access. Yeah, it says you just ignore it.
Okay, just give me a second.
What? It's not me, man.
Oh,
Actually,
wait,
that kind
did
of.
you put that 68? Did you put plus 68 for 14?
This one's too dark. I didn't even get 14. I need a lighter one.
I didn't put plus 68.
I got
I thought I
22.
didn't even do that. And how's it 140?
What's the difference?
Yeah, I got 132. Anybody else get 132? You multiplied 6 for 14? You multiplied 68 and -2. It's 132. Wait, 133. That's it. Thank you.
I got 62.
There you go. There's your numbers for 14. Oh, it's because I put home with 6.
Wait, what do you want?
Weird stuff.
So fun doing them without any